Welcome back to the chapter on arithmetic progression, and now we are going to get to terms of an arithmetic progression. In this video we will be discussing what the terms of an arithmetic progression are. So I hope you remember this graph from our previous videos. This is the graph of the study pattern of someone 1 week before an examination, and we said this was a sequence and we named the terms from T1 to T7 in the previous video, if you remember. Now what if I tell you that this sequence is an arithmetic progression or an AP? Now from the definition of an arithmetic progression or an AP, you remember that it is a special kind of sequence. Okay, so what is the specialty? The specialty is that there's a constant relationship between any two consecutive terms of the sequence, and that relationship is that there is a common difference. So if I call these terms by their names from T1 to T7, I just named the sequence like we've done before, and the nth term would be Tn. So if you look at these terms, each of these blue bars, there is a constant difference, right? Each bar increases by the same amount from the previous bar. So T2 is just 1 unit higher than T1, T3 is 1 unit higher than T2, T4 is 1 unit higher than T3, and so on. So this constant difference between any two consecutive terms, any two terms next to each other, we call D, which is the common difference. I repeat, this D is called the common difference of the arithmetic progression. So once you know that a sequence is an arithmetic progression, you automatically know that the difference between any two consecutive terms is going to be constant, and that common difference we denote by D. So if you have this sequence again, the same sequence, we can use another system to name these terms of an AP, which is what this video is about, naming the terms of an arithmetic progression, provided you know the first term and the common difference D. So let's call the first term A. Okay, we denote the first term by A, and we call the common difference D. So once you know these two values, you can go ahead and find all the remaining terms of the AP. How? Simply by adding the common difference to the first term and then to each term after that. So the second term, you just add the common difference D to A, and you get A plus D, which is the second term. To get the third term, you again add D to this. So A plus 2D will become the third term. Similarly, the fourth term will be A plus 3D, then A plus 4D, A plus 5D, and A plus 6D. So if you look at each term, you find that, for example, for the third term, you added 2D to the first term. For the fourth term, you added 3D to the first term. To get the fifth term, you added 4D. To get the sixth, you added 5D. So each time you add 1D less than the number of the term. So from this, you can say that the nth term, which earlier we had called Tn, okay, the nth term, that will equal to A plus n minus 1 times D. So A plus n minus 1 into D. This will be our formula for the nth term when we have used this system of naming an arithmetic progression. We start with the first term A, and we just go on adding the common difference D to find all the next terms of the arithmetic progression. So I hope everyone understands this system. Now we move on to another system of naming an arithmetic progression. So if you're given an arithmetic progression with an odd number of terms, so let's say you have an AP with 7 terms, okay, an odd number of terms. According to this system, you find the middle term. In this case, it will be the fourth term, T4, and you call it A. Okay. In the previous system, we had started with the first term. We called that A, and we went on adding the common difference D to each term to get each next term. Now what you do, you may name the middle term A, and to get the higher terms, you add the common difference, just like we did the last time. So the higher terms are going to be, the next one will be A plus D, after that A plus 2D, then A plus 3D. And to get the lower terms, you subtract the common difference from A. So the term before A will be A minus D, before that will be A minus 2D, and the first term will be A minus 3D. So for an odd number of terms, I repeat, you name the middle term as A, then the higher terms you keep adding the constant difference. To get the lower terms, you keep subtracting the constant difference or the common difference. Now what do you do for an AP with an even number of terms? So let's say you've got this AP with 6 terms. Okay, there are 6 bars, each bar is a term, so 6 terms. Now you have 2 middle terms. So you can't name them both A, right? Because there has to be some difference between them. So what you do is the bigger middle term out of the two middle terms that you have, the larger one you call A plus D and the smaller one you call A minus D. Now there is still another pitfall that you need to be aware of. Okay, the next higher term is not going to be A plus 2D. Why? Because if you look at these two middle terms, you will realize that the common difference is now not D, but now it is 2D, twice D, because A plus D minus A minus D will become 2D. So now your common difference is no longer D, it is 2 times D. So to get the higher terms, you will have to add 2D. So A plus D plus 2D will give you 3D. So the next higher term will be A plus 3D. Similarly, the next higher term will be A plus 5D. And likewise, to get the lower terms, you will have to subtract 2D. So the lower term will be A minus 3D, and after that, the first term is A minus 5D. So this is the way to name an AP with even number of terms. So just to recap, if you have an AP with even number of terms, you name the middle two terms A minus D and A plus D, and remember that the common difference is 2D, not just D. And if you have an AP of odd number of terms, then you just name the middle term as A, and you keep adding the common difference D to get the higher terms and subtracting D to get the lower terms. Now coming back to the first system that we looked at for naming the terms of an AP, that is, we name the first term A and then the subsequent terms we just add multiples of the common difference D. So we get A plus D, A plus 2D and so on. If you look at the sequence, it's an ascending progression, meaning every term is bigger than the previous term, right? So the second term is bigger than the first term, the third term is bigger than the second term, the fourth term is bigger than the third term and so on. It keeps on increasing. So in this case, what can you say about the common difference D, which is being added to each term to get the next term? D must be greater than 0. That is, D must be a positive number, because only when you add a positive number to something, you get a higher number or a bigger number. So since this is an ascending sequence, we can say that D is greater than 0. Now what would happen in the case when D is less than 0? So if D is a negative number, what do you think the progression would look like? It would be a descending progression, right? Each term would be smaller than the previous term, because if you add a negative number to something, what happens to it? Does it become bigger or smaller? It becomes smaller. So when you add a negative common difference to a term, you get a smaller term. So in this progression, every term will be smaller than the previous term, making it a descending progression. So we've looked at an ascending progression when D is greater than 0. We've looked at a descending progression when D is less than 0. What do you think would happen in the case if D is equal to 0? So let us see. If D is equal to 0, then we get what is called a constant sequence. Why do we call it a constant sequence? Because every term is the same. A is equal to A plus D is equal to A plus 2D is equal to A plus 3D, because whenever you add 0 or some multiple of 0 to something, you end up with the same number that you started with. Nothing changes. So when D is equal to 0, you get a constant sequence, right? So this is the end of our discussion about the terms of an arithmetic progression. In the next video, we will begin with the real exciting part, the meat of this chapter on arithmetic progression, which is problem solving in arithmetic progression. So until then, take care and thanks for watching.